Here's some examples over chapter 6.2, and it is broke down into your 4-step process. So it says research has shown that the mean length of a newborn Pacific Harbor seal is 29.5 inches and that the standard deviation, the sigma, is 1.2 inches. Suppose that the lengths follow the normal model. Find the probability that a randomly selected pup will be less than 29 inches. So the first thing you're going to do, step 1, give the distribution. N, which again means normal distribution, mu, sigma, and so 29.5, 1.2. What we're looking for is a probability that x is less than 29. Step 2, you find your z-score, your 29 minus your 29.5 divided by your 1.2. Then you end up with simplifying the top divided by the bottom and a negative 0.42. You draw your picture. When you're drawing that picture, again, make sure you do your title, your labels. So I said baby seals, inches. My 29.5 goes in the middle, and then I add 1.2 each time to get out there. I subtract my 1.2 each time to get below. Then I was looking for less than 29. So I go here where approximately 29 is. I shade below it. Then I go to the back of my book again, and I'm looking for the negative 4.2. So I go down where the negative 0.4 is, but then I have to come from the top to where the 0.2 is, and I have to find exactly where they intersect right there at 0.3372. And so, since it's shaded to the left, we don't do any subtracting. And I say the probability that a newborn seal pup will be shorter than 29 inches is about 33.72%. And there's your 4-step process. If they ask us to use the same information, and find the probability that a randomly selected pup will be more than 32 inches. Again, we'll go through the same process where we do our N, normal distribution. We're looking where x is greater than 32. We find our z-score. It's a positive 2.08. We draw our density curve again. Again, we label it. We shade where it needs to be. Then we go to the back of our book and we find our 2.08. This time, since our shading is to the right, we have to do a 1 minus the number that we find. And so then what we say is the probability of a newborn seal pup being longer than 32 inches is about 1.88%. The next one where we do one that's in between, what we have to do there is, again, we'll do our N for our normal distribution. Then we'll write it as 27 is less than x, which is less than 31. We have to find two z-scores. So we will find the 27, then we will find the 31. When we draw our density curve, again, we have our title and our labels. Now our shading's in between because we wanted to know the probability that it would be in between there. So what we're going to do is go to the back of our book again, find our numbers, and then we're going to have to do some subtracting because this number here, if you do the probability all the way below it, again, your book has that in the back, so then we would leave that as our 0.8944 minus, and then we don't want to include this little bit over here that's not shaded, so then we'll just subtract whatever's left there which is our 0.0188, and we end up with 0.8756. Therefore, we say the probability that a newborn seal pup will be between 27 and 31 inches is about 87.56%.